I'm on to 3b next. So 3b, and if I just go all the way back into the past here. Oh, nope, doesn't exist actually. Never mind. So 3b. Give your answer. Find the angle BCA. Now, once again, I'm just going to write down what BC and A is. A is 0, 0. B is 6.50. And C is 10, 7. Now, I'm going to do a rough diagram of this again, similar to what I did earlier. Uh, we'll see how it goes. There we go. So A is here. B is 6.5, so 3 plus 6.5 is there. And then C is 10, so that's 7, 8, 9, 10, up 7, and there's C. Okay. And what it wants from me is the angle, it wants the angle BCA. B to C to A. So it wants this angle here. Now, you could do the cosine rule if you wanted, where you do A squared, not this A squared, if you get what I'm saying, just the generic cosine rule. B squared plus C squared minus 2BC cos A. Essentially, get the length of the yellow line, the purple line, which would be this angle would be that one, and you could get the length of each one by using the distance formula. Now, it's quite time expensive to do it this way, so I'm not going to do it this way because I don't want to spend too much time on it. It'll just take too long for my liking. So what I'm going to do instead is the way I'm going to do this question is, you might have remembered from the coordinate geometry chapter, we had this formula where if you have two lines and if you have one slope, m1, and you have another slope, m2, find the angle between, you can find the angle theta using tan theta equals m1 minus m2 over 1 plus m1 times m2, if I remember correctly. Now, I'm always going to check my actual formula here. There it is there, plus or minus m1 minus m2, 1 over m1 times m2. So I'm going to use that. Sure, why not? Yeah, it's plus or minus here. Okay. Now, I need to find the slope of if you will, if I was to continue this line along this way, and this line along this way, I'm looking for the acute angle between the two of them. So I need the slope of the green line, and I need the slope of the blue line. Okay, now I can use the slope formula twice if I want. So just call this x2, y2, and call this one x1, y1. Now we're going to use the slope formula twice, y2 minus y1 over x2, take away x1. So I'm going to get the slope of BC. Now, slope of BC is 7 minus 0 over 10, take away 6.5. And I think I had it in the previous question, so the slope is 2. No bother. And then we're going to get the slope of A to C. Slope of A to C is going to be, it's the y value is going to be 7 minus 0 divided by 10 minus 0. This is for the slope of AC. Slope of AC is where this is x1, y1, and x2, y2 is 10, 7. And what we're going to get is a slope of 10 over 7. Next thing, I'm going to label these. This one, yellow can be M1. Or sorry, blue can be M1, and yellow can be M2. And this is a nice quick way of doing this question, if I'm being honest. It's a nice easy way of doing it. So tan theta ends up to be M1 minus M2, so 2 minus 7 tenths. 2 minus 7 tenths all over 1 plus 2 times 7 tenths. Now I'm going to let my calculator do all the work for me. So I'm going to do 2 minus 7 tenths, which is 0.7. 1 plus 2 times 7 tenths, which is 2 times 0.7. Enter in 13 over 24. So tan theta equals plus or minus 13 over 24. I'm looking for the plus version because I want it to be an acute angle. So I'm going to tan inverse 13 over 24. So tan inverse 13 over 24. What I should get, shift tan inverse 13 and divided by 24. We get 28.44 degrees. I reckon that's reasonably accurate because it is the smallest length in the triangle. So it should be opposite the smallest angle by logic. So, but we will check the marking scheme if I have it here. Here I always check the marking scheme. Oh, thank God. 28.44. Everything's good. Alright, let's move on. Question 4. Two circles S and S touch internally at B. As shown. The equation of circle S is this much here. So what I can do with this is I can find the center of it. So I'm going to compare it to going to be x minus h squared plus y minus k squared equals r squared. Now, r squared equals 360. So I need to get the square root of 360 to find the r value. And that is 6 root 10. So 6 root 10 for the radius. Next thing, the center. Well, the center is hk. And h is equal to 1. And k is equal to minus 6. Just by direct comparison. Minus k equals plus 6. And minus h equals minus 1. Gives you h equals 1. K equals minus 6. So this is the point 1 minus 6. Okay. The point K is the center of the circle C. No bother. The radius of C is 1/3 the radius of S. Okay. So, basically, radius of S, black line, and radius of C is 1/3. 1 second. So essentially, what I'm seeing is that uh, this yellow line, this green line is 1/3 the length of the black line. Yellow line equals the green line because they're both the same length, and then this blue line, all three of them are the same length. Okay, so that's what I'm getting from this. It says the coordinates of B are 7, 12. So B is 7, 12. Now I think we have this, lads. Imagine it's 2/3 of the distance. K is 2/3 of the distance away from the point 1 minus 6. Because imagine the full distance as 3x from here to here. But then then to get from this point to K is 2x, or 2/3 the distance. So I reckon we're 2/3 the distance. Okay, so get this, we're going to do a translation, okay? So we're going to do 1 to minus 6, and we're going to see how far it takes to get to 7, 12. So 1 to 7 is plus 6 to the x value, minus 6 to 12 plus 18 to the y value. Now, we want 2/3 of this distance, so multiply it by 2/3. So we're going to do 6 multiplied by 2/3 is 4. So we're going to do plus 4 to x, and we're going to do plus 12 to y. And what we should get for the coordinates of k are the points 5 and minus 6 plus 12 plus 6. So the point 5, 6, I'm hoping. Now, once again, I will check as I go along. B part 1. Where are you, B part 1? Ratio 2 to 1. Yeah, 5, 6. Happy out with that, okay? They have a different way of doing it than me, but look, all good, all good. Now, B part, find the equation of C. No bother. what do we know about C? We have the center of the circle is 5, 6. So we know the center of the circle is 5, 6. So that's 5, 6. And this is 7, 12, I believe. Check. So I can find the radius by using I could use the distance formula here, or you can use the distance like x2. You can use the geometry distance formula, but I'm going to be a bit lazier than that because I know a shortcut only for this question is that hold it's 1/3 of this. So 1/3 of 6 root 10 is 2 root 10. So I know radius is 2 root 10. Handy for me because then I can just use x minus h squared y minus k squared equals r squared. So I can just say it's x minus 5 because that's hk squared plus y minus 6 squared equals r squared. R squared is 2 root 10 squared, so 2 root 10 2b squared. Throw that into the calculator, you're going to get 40 all day long. Right? And we'll check my answer. Yeah, good. Now, next question. Find the equation of the common tangent at B. Give your answer in the form ax plus by plus c. Alright, no bother. Common tangent at B. Common tangent is this guy here. Okay. It goes through 7, 12, and it has to be perpendicular to this blue line here. So I'm going to find the slope of the blue line, and then find the slope of the blue line, and then you can use the slope formula, slope of the blue line, and then find the perpendicular slope and use the equation of a line formula. So it's going to be equation of a line, which is y minus y1 equals m into x1. You already know the point is 7, 12, so you can get some attempt mark straight away by just writing this. And the only thing you need now is the slope. Well, what we learned earlier is that it has a slope of what is it? 6 across and 18 up. Okay, so if you want to do it, it's going to be 12 minus 6, y2 minus y1, y2, and this can be x1, y1, and then the other one's going to be what 5 5 minus 1, correct? Yeah. Oh, sorry. 7. I'm using 7 and 12, so it's 7 minus 1. Doesn't it for a minute? And that's actually 18 over 6, which is a slope of 3. So the slope is 3. All you gotta do is the slope of 3. 3 into x minus 7, y minus 12. I'm telling you, these questions have gotten easier over the years. Minus 3x plus y minus 12 plus 21 plus 9 equals 0. And there's your answer. A, B, and C are elements of Z. So that's one possible answer. You can multiply both sides by minus 1. And you can get this as a second answer. Both answers are acceptable. Once again. Oh, mistake. Slope is 3, which means the perpendicular slope is a third. Sorry guys, I was meant to use the perpendicular slope, not the slope of 3. So remember, the blue line has a slope of 3. Sorry, this blue line has a slope of 3, but the black line has a slope of minus 1/3. Now therein lies the importance of checking your answer. Multiply across 3y minus 36 equals minus 1x plus 7. Move everything to the one side and you're going to get x plus 3y minus 43 equals 0. And that's your answer. Okay. Alright, let's keep going. This one. The center of the circle lies on the line x plus 2y minus 6. The x-axis and y-axis are tangents to the circle. There are two circles that satisfy these conditions. Find their equation. Now, I think it'd be interesting to actually have a look at this line. So I would intentionally draw this line. So what I'd do is I'd find out where it cuts the x and y axis. So I'm going to say when I put x equals 0, I'm going to get 2y minus 6 equals 0, 2y equals 6, y equals 3. 0.03. So it crosses here. Nextly, the next thing we're looking at is uh, when y equals 0. When y equals 0, 2 times y is 0. Bring the 6 over to your side, and x would equal 6. So that's the 0.60. 1, 2, 3, 4, 5, 6. And there's 6, 0 for you. Okay. Now, what I'm interested in here is that it says that the x-axis and y-axis are tangents to the circle. And these two circles satisfy these conditions, right? So it's something like this. Like it can be a circle of any size as well. So imagine something like this, and I have to drag this along, or I can make it bigger or smaller depending on what I'm trying to do here. Okay, so I'm thinking something like this. I tend to visualize as many of my questions as I can. Center of the circle. I think I almost have this one sorted. Just made it a bit bigger. I think there's going to be something here where the center of the circle is going to be. There's going to be some. It's going to be somewhere over here where it touches both axes at the same time. And then what's going to happen is it won't do it there, but and it's that's it. If I made it a lot smaller, like the circle isn't always going to be the same size. Made it a lot smaller. Ah, I could perhaps make it work here. Something like that, maybe. I think there's some sort of like, that's what I'm visually thinking at the moment, alright? Now, what we learned in the previous video, that's just me visualizing it. I didn't really get much out of trying this out. Now, what we know about what we know about when the x the y-axis and the x-axis are tangents, what always happens in a case like this is that you write down g squared equals f squared equals c. Now, what I mean by this is that example would be you could have a point. You could have a point here. Let's say a center of the circle could be 3, 3. It could be 1, 1. It could be 2, 2. It could be something like that. In this case, the g value and the f value squared will equal each other. Okay? Or you could have a center of a circle over here, which could be, I don't know, for argument's sake, minus 5, 5. In this case, minus g minus f, g squared f squared would equal each other as well. So that's what we're looking at. Okay? The g squared equals the f squared, right? So, for argument's sake, the center of this circle, don't currently we don't currently know what it is or where it's going. Okay? So we're just going to call the center of the circle minus g minus f. And that's what it is, okay? Now, find their equations. No better. Okay, so here's what I'm thinking. Point minus g minus f, which is the center of the circle, lies on this line here. So what I'm going to do is this point must satisfy this line. So I'm going to replace x with minus g and y with minus f. And then we get 2 times minus f, which is minus 2f minus 6. Then What we also know is that g squared equals f squared. And what I see here is like a simultaneous linear quadratic equation. One's quadratic, one's linear. Top one's linear, bottom one's quadratic. I'm going to isolate g on its own. I'm going to get g equals 2f minus 6. And then I'm going to substitute in I'm going to substitute in 2f minus 6 for g. So I'm going to get 2f minus 6 squared equals f squared. Going to multiply that out. So 2f minus 6 by 2f minus 6 equals f squared. And what I'm going to get is 4f squared minus 24f plus 36 equals f squared. Bring it over. And I'm going to get 3f squared minus 24f plus 36 equals 0. I'm going to get f squared minus 8f plus 12 equal to 0. Then I'm going to get f minus 6, f minus 2 equals 0, f equals 2, and f equals 6, right? Then I'm going to try and get two g equations then. So what is g going to be? So g is 2f minus 6. Check that. Oh, made a mistake. Actually, yeah, I did make a mistake. It's g equals minus 2f minus 6. So that's actually a plus 24, which is perfect. That's a plus 8, plus 6, plus 2. That means f equals minus 6 and f equals minus 2. So f is minus 6 and f is minus 2. F is minus 2 and f is minus 6. And sometimes the simple things that get you. The idea is correct, but the execution is wrong. Now, here's what we're going to do. We're next going to go back up and we're going to say, oh, g equals minus 2f minus 6. No bother. So then the g value is going to be minus 2 times minus 2 minus 6. So this g value is going to be minus 2. So when the f value is minus 2, the g value is also minus 2. And then this time we're going to try minus 6. So in this case, when the g value is minus 6, the f value, when the f value is minus 6, the g value is going to be plus 6. Now please remember, the circle has a specific value. I have to find the equation of both circles. Find the equation of both circles. I should be able to do this, alright? What's going to happen is one of them has, and in both cases, we know the c value. Remember, g squared equals f squared equals c. So c is going to equal 4. And in this case, c is going to equal 36. And all I need to do is do x squared plus y squared 2gx plus 2fy plus c equals 0. And what I should get for both equations is this. And let me find out. It's going to be x squared plus y squared minus 2gx. So it's going to be minus 4x. And then the other one's going to be minus 4y. And plus c is plus 4. And that equals 0. That's one equation. And then the second equation is going to be x squared plus y squared minus 2gx, which is going to be minus 12x because g is 6. Replace g with 6 and replace f with, oh, sorry, plus 12x minus 12y plus 36 equals 0. Now, I'm quite fortunate that I can check my answer. So here's what we're going to do. We're going to check our answer here. So I'm going to put in this equation x plus 2y minus 6. We drew it earlier. So here's x 2y equals 0. You should see the line that we drew earlier is right there. Next thing I'm going to do is I'm going to draw, I'm going to draw that one we just had. So it's x squared plus y squared. Now I'm hoping it appears, hoping when I draw this, it appears on the line. So minus 4x minus 4y plus 4. So minus 4x minus 4y plus 4 equals 0. Oh, I typed it in. And equals 0 at the end. Equals 0. There it is. A circle that is on the center of a circle that is on our line and touches the axis twice. Very certain I got that one right. And then the next one is plus 12 minus 12 plus 36. Plus 12 minus 12 plus 36. So x squared plus y squared plus 12x minus 12x plus 36 equals 0. And long behold, whoop, undo that last part. Now, where is it? Currently, I don't see that circle I drew a second ago. Doesn't quite exist for me at the moment. So where exactly is it? X squared. Uh, hmm. The equation 2 has disappeared on me for some reason. I'm trying to figure out where did it go. Surely it's hmm. Seem to want to draw it for me, which I don't. Alright, I'll just go back to the start and try and put it in again. Just paste this. X squared plus y squared. Yeah, and technology fails. Alright, let's just go back to the start and try that again. I'm just going to modify this one up here. See if it works for me. Plus 12x minus 12y plus 36 equals 0. And I want to get rid of all this nonsense. And there it is. Alright, so that's the second circle that touches only once and it's on this line. Sorry about that. Don't know why that didn't work the first time. But look, there we go. Found it in the end. Alright, so both equations are perfect. Don't need to worry about it. Now, circles C1 and C2 touch, they touch externally. Shown. Complete the following table. Okie dokie. Alrighty. So we know that C1 has a radius of 2, has a center of this. And we know the equation of the second one. So what we're going to do is we're going to figure out. Here, this is relatively easy. Alright, I'm just going to call you HK and call you R. So it's H minus K squared plus Y minus K squared equals R squared. R squared is 2 squared, which is 4. That's going to be X plus 3 squared. And that's going to be Y plus 2 squared. Because it's K minus minus 2. X minus minus 3, which is plus 3. And that's an acceptable answer. Or if you were to square it out, you'd get this plus 4y. 9 and 4, which is 13. Bring the 4 to the other side is 9. Have that answer if you want. Whichever answer you want will do you. There's no reason why you can't use the first answer. X plus 3 squared, your y plus 2 squared equals 4. Now, on this formula here, I'm going to use the, on this, on this one here, guys, what I'm going to do is I am going to use the x squared plus y squared plus 2gx plus 2fy plus c. Do the business for me. Okay. And when you do this, you should get uh, minus 2x is 2g, so 2g equals minus 2, g therefore equals minus 1. 2f equals minus 2y, so f also equals minus 1. This means the center of the circle is minus g minus f, otherwise known as 1, 1. Radius is g squared plus f squared take away c. The c value is minus 7. So what we're going to have is minus 1 squared plus what is 1 squared, and then minus 7. It's going to be square root of 9, which is 3. So what we have here is minus 3 minus 2. We have the point 1, 1 up here, and we're looking for the coordinates of the point of contact of C1 and C2. So looking for the green point here. This is going to be a relatively easy one to do. So what we're going to have here, guys, is, sorry, I don't even know I'm rubbing all that out. What we're going to have here is, that's a ratio of 2 is to 3. Okay, so distance of 5, and 2/5 of the way there is going to be the green point. So from this black point to the green point is 2/5 of the distance. All I'm going to do is I'm going to examine how would you get from this center to this center. So what I mean by that is, how would you get from the yellow point all the way to the blue point, and then I'm going to get 2/5 of that distance. So how would you go from minus 3 to plus 1? Add on plus 4 to x. How would you go from minus 2 up to 1? You go plus 3 to y. Now what is 2/5 of that distance? 4 multiplied by 2/5 is 8 over 5. So we're going to do plus 8 over 5 to x, and then 3 times 2/5 is going to be 6 over 5. You're always a bit wary when you have fractions in your answer. So it's going to be minus 3 minus 2. Now you're going to add on your 8/5 to minus 3. So minus 3 plus 8/5. Whoop. Minus 3 plus 8/5. And that should get me to point minus 7 over 5. So that's minus 7 over 5. And then minus 2 plus 6/5. And we get minus 4 over 5. Once again, I'll probably just check my answer. Hope I got it right. Yes, I did. Happy days. Alright, let's move on. Nearly done this video. It's like 10:30 at night here on our Wednesday. Shouldn't be working, but need the time off tomorrow. Stupid babies. Now, let's keep going. Hence or otherwise, find the equation of the tangent t common to C1 and C2. Okay, now believe it or not, there's the easiest way ever to do this question. You take away the equation of the first circle, take away from the equation of the second circle, and you get the common tangent. So I'm going to take the two of these guys here, these two equations here. I'm just going to keep it on this page for a second, and you're going to see that the little trick that we're going to do to get this done. Now, there's plenty of ways to do this question, right? So if you want a more conventional, longer route of doing it, which probably makes a bit more sense, what you do is you get the slope of. I'm just going to rub a lot of this stuff out for a minute. Just going to rub this nonsense here, all right? What you do is you know this point already. You know this point is -7/5, 4/5. Okay, and what you do is you get the slope of this blue line here, then get the perpendicular slope, which would be the slope of the tangent. If you have a slope and the point, you can use the equation of the line formula to find it. That's all well and good. Takes a bit longer. What I'd be doing is this. I'm just going to do x squared. Remember, I multiplied this out earlier. I'm going to get x squared plus y squared plus 6x 4y. There's going to be a 9 and a 4 there. And then there's going to be 9, a 4, and then there's going to be a -4. So it's just going to be plus 9 at the end. And what you do is you just take away these two equations from each other, and it gives you the common tangent every time. So just C1 take away C2. Such an easy job. So I'm just going to take them away. Minus, minus, plus, plus. And what I should get is 8x plus 6y plus 16 equals 0. Divide both sides. So we get 4x plus 3y plus 8 equals 0. I'm going to check if I'm right. And yeah, there it is. No bother. Easy trick. Okay. Oh, guys, I think we're done. I'll check if there's anything else.